Alright, today we're going to work on finding an angle when you're given two side lengths using inverse trig functions. So far we've been using trig functions, sine, cosine, and tangent. Inverse trig functions are just inverse sine, inverse cosine, and inverse tangent. So it's when you're given a ratio, and you must use the ratio to find that angle. Example, right here across from x, I have the opposite side, and I have the hypotenuse. I can write my SOHCAHTOA up top to help me. And since I have the opposite and the hypotenuse, that's OH. That tells me to use inverse sine, because sine of x is 6 over 12, opposite over hypotenuse. That means when I take the inverse sine of both sides, I end up getting back to x. So x is the inverse sine of 6 over 12. Now I can reduce 6 over 12 to be 1/2. And the inverse sine of 1/2, I could write into Google a sine of 1/2. And then that should give me, as long as I specify that I'm using degrees, that should give me back my 30 degrees. Basically what we're saying is that a degree measure of 30 has a sine ratio of 1/2. In this case it's 6 over 12. If it were a differently sized triangle with 30 degrees instead of 6 over 12, it might have been 4 over 8 or 3 over 6 or anything. That reduces down to 1/2. That is the power of these trig ratios. Let's look at the second one. So first I need to identify which sides I have. If this is my x, this is my adjacent leg because it's the one that's next to it. And this one is the hypotenuse because it's across from my 90-degree angle. So in this case I have A and H. Then I look back at my SOHCAHTOA. That tells me that I have cosine because cosine goes with the adjacent hypotenuse leg. So I can write that cosine of x is adjacent over hypotenuse, 4 over 8. In this case, it's also 1/2. However, since cosine of x is 1/2, I'm going to have a different measure than I did before. So when I take the inverse cosine on both sides, I write that by writing cosine to the -1 power. That means I get just back to x because these are inverse functions. Inverse cosine undoes cosine. I get back to my x value. So inverse cosine of 1/2. Into Google, I could type a cosine of 1/2, and as long as I specify that I want degrees, it should give me my 60 degrees. So this one is double the measure of the other angle. It is 60, and we used cosine because we were given the adjacent and the hypotenuse legs. The last one, we can identify the legs we have. We've got the opposite side from x, and we've got the adjacent side right next to x. We do not have the hypotenuse. So I look up at my SOHCAHTOA, opposite and adjacent. That tells me it's tangent because it is TOA, T, opposite, adjacent. So I can say the tangent of x is opposite over adjacent, which in this case is 8 over 8. That's actually 1. So when I take the inverse tangent of both sides, I end up getting x is the inverse tangent of 1. And you can type that in Google as a tan 1. And that should, as long as we specify that we want it in degrees, that should give us our 45 degrees. Just be careful when you're using Google to do arctangent. That's what the A stands for. Inverse tangent is also called arctangent. It's just a matter of what we call things. And just specify that we're using degrees. If not, they might give it to you in radians, which is a different measure that we haven't talked about yet. All right, best of luck.